Hello students, how are you? In this video we're going to complete part 2 of paper 1 multiple choice for core 12 February March 2024. You remember in the first part we finished until question 10, so today we're going to start with question 11. Okay, so question 11 says, which row describes how the volume and mass of liquid mercury change as it is heated? Okay, remember, let me remind you of something regarding the mass. The mass shows me or gives me the amount of matter inside the object, if it's solid, liquid, or gas. So basically, if it is heated or cooled, the number of particles doesn't change. The only thing that changes may be the distance between them. Okay, so in general, the mass doesn't change. Okay, the mass doesn't change. So it's either option B or D, right? Option A is wrong and option C is wrong. Okay, so regarding the volume, we know with heat the volume will increase. Why? Because the particles will separate from each other, so there will be bigger volume. So it's option D, right? I hope it's clear. Question 12 says, in which situation does the store of internal energy of water increases? Okay, internal energy of water, when does it increase? So in A it says water at 0 Celsius degree freezing to form ice. Actually no, the internal energy will decrease with decreasing the temperature. In B, water being heated from 25 Celsius degree to 40 Celsius degree, and this is correct because the heat energy will change to kinetic energy, which means the internal energy of the particles of water or any liquid will increase. So option B is correct. Okay. In C, they're asking or they're saying steam condensing on a window. In condensation, the steam will lose energy, right? Here they say water in a puddle on a breezy day. A breezy day will cause the water to evaporate. And as we know, evaporation, it doesn't need heat, so there's no increase of energy. Okay? So it's option B, which is correct. Let's go to question 13. It says, which statement describes what happens to particles during evaporation of liquid? As we said in the previous question, evaporation doesn't need heat. It only represents the escaping of particles from the liquid. So in A, they say particles become fixed. No, actually, they don't become fixed. In B, they say particles escape from the surface. Exactly, that's what happened in evaporation. In C, particles move much closer. No, this is wrong. In D, particles start to move around. No, actually, they are moving around. Yani they don't start to move around, okay? So it's option B. Question 14, which of the following is not an example of convection? Let's remember, convection happens in fluids, okay? Either gases or liquids, okay? The thing that happens in solid, we call it conduction. In option A, they say a spoon handle becoming hot when it is placed in a hot drink. Since the spoon handle is solid, so this is conduction, it's not convection. So A is not convection, so it's most likely this is the correct answer. It's not convection, so this is the correct answer because they're saying not convection. Let's make sure of the others. Thermal updraft in the atmosphere that glider pilots use. Yes, actually here there will be convection, okay, because the air particles will move up. Flames and smoke rising from a fire, convection. Warming up water in a kettle, convection. So the one that is not is a spoon handle. Question 15. A hollow aluminum cube is filled with very hot water. Okay, so here I have hot water, very hot water. Okay, side X of the cube in the is opposite side Y of the cube. One of these sides is black and one is white. Okay. Now, a student holds the back of one hand 5 centimeter from X here, okay? And then immediately holds the back of the other hand 5 centimeter from Y in here. Okay, let's complete. The hand held near Y feels warmer. So here, warmer. Okay. Warmer than the one held near X. Which row identifies the black side and correctly compares the rate of emission of thermal radiation for each side? Since Y here is warmer, it means this is black, because we know that black is an excellent emitter, right? So the black side is actually Y. It's either option C or D. A and B are wrong. Okay, and then they say here, they say rate of emission of thermal radiation. Here they say greater for Y, here they say same. No, it's not the same for X and Y. No, this is wrong. So the correct option is C. The black side is Y and it is greater for Y. It means greater than X. Okay. Question 16 says the diagram, let me choose this, shows a ray of light traveling from air into glass, okay, and changing direction so that it is closer to the normal. Okay, what is the name of this process and why does it happen? Remember, when the light changes direction when it goes between two mediums, this is called refraction. Okay, so A is wrong, B is wrong, so refraction. And the reason is there's a change in speed. Okay, but we need to know, since the density of glass bigger than density of air, this means that the speed in glass is smaller than the speed in air. Okay, so the speed decreases. The speed decreases. Okay, this is the reason for light refraction. Question 17. Oh, sorry, let me adjust the frame every time this happens. Okay. Question 17. Which row gives an example of longitudinal wave and describes the direction of vibration? Okay. Light wave is transverse. Sound wave is longitudinal. Let's remember, in longitudinal wave, the particles will vibrate like this, for example, right and left, and the direction of wave will be like this. So it will be a zero angle, or we say they are parallel. So the direction of vibration is actually parallel to the direction of wave. Okay, so in C they say at right angle. No. In D they say parallel to the direction of propagation. Yes, a propagation means vibration. Okay, vibration. Okay, so which statement about total internal reflection is correct? Total internal reflection, this happens, total internal reflection happens when we have an incident angle which is bigger than critical angle. Okay, let's remember what is the critical angle. So let me draw here a boundary between two mediums, for example air and glass. This is A, by the way. Okay, I'll draw here the normal. Okay, let me change the color. Critical angle is when I have an incident angle here and it refracts exactly on the surface. It means I have a refraction angle equals to 90, which means that this is incident angle is critical. We call it C. Okay, so basically critical angle happens when the light goes from a high density to a low density, and the total internal reflection happens when the incident angle is bigger. This is the total internal reflection when the incident angle, all of this, is bigger than critical. Okay, so in this case I will draw I bigger than C. Okay, so let's see the options. In A, they say total internal reflection occur when light is incident on a glass to air boundary, so from glass to air, at an angle of incident greater than critical angle. Yes, this is the correct option. This is exactly what I was explaining. Let's check B. They say from glass to air and incident angle less than critical. No, this is wrong. In C, they say from air to glass. No, this is wrong. As we said, it should be from high density to low density. The same here. It's wrong. It must be from a high density medium to a lower density medium. Okay? Good. So it could be, let me go back here. It could be from glass to air, or maybe water to air, or maybe glass to water. Okay? Good. Question 19 says, a ray of green light passes through a glass prism as shown. Okay, so this is green. It's written here. Okay, green light. Which colors of light refracts as shown in the table? We have here refracts more than green and here less than green. Let's remember how the colors refract. Remember, we have red, orange, yellow, green, blue, indigo, and violet. Right? So the one that refracts more than green, is it red? No. No, the red will be, as you can see up here. So it's going to be violet. So it's either C or D. The one they say less than green, it's yellow. The yellow is still here, less than green. So it is option D. Okay, I hope it's clear. By the way, I hope that you memorize the order of the colors. You must know this order. Roy G. Biv. Okay. The last question for this video, they say which electromagnetic waves are used for sterilizing medical equipment? Okay, I hope you memorize the use of each of the electromagnetic spectrum parts. We all know for sterilizing medical equipment, it is gamma rays. Let's remember, sterilizing medical equipment and sometimes sterilizing food. Okay, and it is used gamma to check if there's any cancer cells, and it is also used for cure for the cancer cells. Okay, so these are the second 10 questions in this paper. I hope everything is clear. Feel free to ask any question under the video. Okay, I'll see you in the next video. Have a nice day. Bye bye.